Hello everyone. My name's Jonathan. Pretty much anyone that knows me calls me Johnny, so we'll just go with Johnny Cope. I'm a maker based in Northwest London, but I'm kind of multimedia in that I work in a wide spread of different materials, but also as well different things. So anything from blacksmithing, silversmithing, leatherwork, woodwork. I'm also part-time extra actor. I wear lots of different hats, let's say. In terms of 3D printing, I made my first 3D printer about must be 6 or 7 years ago now. It was a Printerbot. Tried a few others. I still quite like Printerbot. It's a shame that they failed in the end, though there's signs they may be coming back. So my main printer is a Printerbot Simple Metal, though I've upgraded it. I've done a Z upgrade, a Y upgrade, heated bed, you name it, kind of rebuilt it, re-engineered it, and I run several. And much like many of you, I'm sure, you get a 3D print out, and you know once you've tinkered with it, and obviously I realise people watching may be complete beginners through to experts and beyond. All being well, you get a nice 3D print, and it's great, and they're wonderful things. And I'm sure many of you have tried different materials, and some of them are very strong. But maybe you've found yourself thinking, "Oh, this is great. Wouldn't it be wonderful in metal?" And I found myself thinking that, not just for the look of it, the weight of it, but if you actually want to get into the engineering side of it, if you actually want to make, I know, say, a working gear or something that's going to hold some weight, some structure. That's what led me down this path. So how easy is it? Well, it's not without its problems, but I'll explain some easy ways to get into it at the end. I, for a number of years, have had an interest in ancient history, so that was my way into it. So I 3D printed. This is a model of a Bronze Age axe, which would be hafted onto a handle. And who wouldn't want to turn that? It's really lightweight and everything, but who wouldn't want to make that into half a kilo of solid bronze? Well, me, basically. So that's what we're going to look at. So I'm going to move over now, with Sam's guidance, to a quick PowerPoint, and then we'll come back to live feed, and if there are any questions and things at the end. So let me just pop over to PowerPoint. That's working okay, Sam? PLA, as you can see, it's not fantastic resolution. I was impatient. It's probably run at about 1.4. So it could have been a lot better. I'll talk about that sort of thing at the end. I sprayed it, so I use a standard gap-filling acrylic spray to help smooth it, though there's lots of other things we can do, as I'm sure many of you know. And then the cast there on the right-hand side. So metal casting. Historically, what we've looked at is, not to get too technical about it, but some folks that know anything about this may be familiar with the term cire perdu, which is just French for lost wax. And that's how things started way back in the very beginning, nearly 2,000 years ago. So you'd make something, a shape in wax, you'd invest or embed that in clay. You would then melt that, which baked the clay, and it melted out the wax. You were left with a void inside, and then you would melt metal and pour it in, breaking open the baked clay, and your metal thing was waiting for you inside. What sort of temperatures have we got to work at? Well, I'm working with bronze, so around about 1,000 degrees C. So it's not for the faint of heart. It's not without its problems, as I'll talk about briefly in the safety section. Here's some others that you might want to use, or have seen people use, or be thinking about. Aluminium is the obvious one, because it's still very hot, but aluminium is quite cheap. We can melt down cans and things like that. So lots of people doing that on YouTube. The place to start, maybe if you have never done anything like this before, will be so-called white metal, pewter, or tin. So those of you that remember D&D, or metal figures from gaming, from like Warhammer, those sorts of things, that's this tin alloy, and you can get kits for that, which I'll show in my slide. But this is about 200 degrees, so it's a lot more comfortable, a lot more straightforward. So that's probably what I'd suggest a way to start. So what's involved? Rather than doing the clay version, or investment casting, which is a castable material, it's a lot more laborious, intensive on time, and more expensive, and prone to lots of problems. So the easy way into it is what gets called green sand. Um, this is or Delft Clay is another way you'll hear it called. This was used for many years and still is used in the jewelry industry, and it's effectively a sand-like material. That when compressed, so hit with a hammer, you can see my little rubber mallet there, it starts to behave a bit more like a solid. So it's kind of more like clay. So what I've got there is a two-part mold, which, to use technical terms, is called a flask. You'll put the sand, beat it flat, scrape it flat, and then it's kind of like a clay surface. And then you'll take a master, a former. In this case, this is one I already had in bronze. In the case we're giving here, we'd actually 3D print something, and we'd lay it up against this material and then hammer it in, so it's part way into the surface. This is what's called parting powder. So it's talc, effectively a chalk material, which is powdered all over. The second section of the flask mold is put in on top. These have special lugs that hold them in place, so it's all in register. You put in some more of the Delft clay and you hammer it flat. So it's quite a strong process. So your objects have got to be strong to withstand this, and I'll talk about that in a moment. So once it's all hammered flat, then we can release the mold back open. Hopefully nothing falls off and you're left with this nice clean impression. I can lift out that bronze original, which leaves me a void inside, and then reintroduce the two halves back together again, and clamp them for safety and just to stop them moving one against the other. And now we've got a finished, ready to go flask mold with, if we look down inside there, we'd see a void down inside. And that's what we're going to fill up. So different ways to make melt metal. I'll talk about this towards the end, but this is how I started. So obviously I'm creating bronze. I'm creating the ancient mix of bronze, which is around 85 to 90% copper and the rest tin. So I take those two, introduce them into a crucible, which can take very high temperatures. They're usually made out of graphite. You can see one just in the far distance there, the little sort of pot standing up inside that green shed area, if you like. This was down in my garden. And the white structure you can see there is effectively a foundry, a melting furnace. I built that out of high temperature bricks, and then I used kaolin wool, which is a more recent product, which can take very high temperatures. Not too expensive, but you can cut that to shape and fit it around as a thermal deadening layer, so it helps insulate. And I've got a lid on there with a hole to let some of the air in. So I'm started off using charcoal. So I'd set up basically a charcoal fire, a bit like a barbecue. And then you can see this little black pipe there on the right-hand side, and it's a vacuum cleaner on blow, as simple as that. And that's blowing air into that rusty-looking pipe, which is just what I had to hand. Like a lot of makers and tinkerers out there, we tend to keep things lying about, why ever throw anything away? And that introduces oxygen into this environment, which greatly heats up the charcoal and rapidly builds the temperature up to many hundreds of degrees. You'll see just also up at the very top of that picture a little yellow device, and that is a temperature monitor, and that has a wire which feeds and through a little hole in to the edge of the furnace to monitor the temperature, so I can actually see what's going on inside. I can use tongs, some safety tongs to lift the lid off and have a look if I need, but ideally I want to keep that heat inside. So we're ramping the heat up, and then this is bronze, so it's about 1,000 degrees. I'm using tongs, and as you see, all safety devices, special aluminized gloves there to protect from the heat, because it really does feel very hot. Even on a cold day, it radiates heat towards you. Lifting that crucible up with the molten metal, and it's quite a magical process of actually pouring that then into this mold, which partly burns the sand, but it very quickly wicks away the heat. So then putting the crucible out of the way and breaking open, I can actually take the original thing out. This was We've changed now to a different day. This is a little, hopefully obvious, sharp, what's called a tanged spearhead. That was also 3D printed from an original, and I made a batch of these that were used in a film where they were reenacting spears from that particular time. So this is then quenching this 1,000-degree cast heat into handleable cold temperature very quickly. It all happens really quite quickly. It's quite magical, actually, seeing the molten metal turn into a hard object like that. So here are some bronze axes of different kinds that started out as 3D prints and then got cast. And then I'm expanding into all sorts of other objects. So the things at the bottom, you might recognize those as Viking Mjolnirs or Thor's hammer, worn by Viking raiders, if you're into such things. We've got a little spearhead over there on the right-hand side, and the little smaller things around are various chisels and razors and so on, with an axe in the middle. So I ran that setup for quite some time, and it was perfectly fine. But then now started to do this sort of more commercially. I also run workshops teaching people how to do this. So just to make it quicker and more efficient, I moved to a propane foundry. So this one was made in Bulgaria. The brand there that you see is called Devil Forge. So it's all a lot more robust. This is a metal shape with what's called cast refractory inside. So it's effectively like a kind of a high temperature cement, which is then dried, which holds the heat in. Obviously, a little hole to allow the gases and everything to escape and allow a tiny bit of oxygen to come in. What we can't see hidden behind the white plank there is the propane feed. So you set a burner going in and then adjust the oxygen that gets pulled in from the ambient air, and very quickly again ramps up this temperature. I've created better and better devices to safely lift the crucible out and place it in that big iron there, which lifts it up and allows me to pour it in that waiting flask. So we might not want to all dive into that level because it really takes quite a bit. Actually, I'll just move back to that slide. Just this kind of kit. We're not talking huge sums of money. If you think this is something you really want to do, or have always wanted to try, or think, yeah, that's for me, and you've got the space and the wherewithal to do it, we're talking about £800, I guess, to start buying all this equipment. About 500 will buy you the forge. If you want to start off with this sort of DIY build, like I did, then you can cut that down to only a few hundred, some special bricks and so on. So that's a lot more affordable. This sort of thing, you're looking at a bit more, just because it's more professional kit. It's going to last a lot longer and do the job more efficiently. So you choose your level, where you want to be in terms of hobbyist, or whether you're going to use it professionally and so on. But those of you that have bought or built or working on 3D printers, it's not beyond the price of most sort of 3D print setups. Really, it's probably comparable, and very, very similar. I'm sure many of you remember the sort of learning curve. Sort of start off small and then upgrade and add new bits. Well, that's what I'm doing with this casting. So not many folks will want to or need to go straight into casting bronze. So probably won't need some of that setup that I'm showing there. So how can the average person pop into this, start this just at home with simple setup and cheaper? So this stuff is our friend. Those of you that tried other media, if 3D printing, I find people tend to build in other materials or have an interest in building and making and all this sort of hobbyist level stuff. You might have become familiar with this, which is a silicon-based putty. It's in two parts, in the two pots. You mix it together, and then you've got a certain amount of work time before it sort of sets and it goes sort of semi-hard or flexible. There's different grades of it, but that's really, really useful. So what I suggest as a way to start really is, rather than thinking a fully three-dimensional shape, I kind of work backwards in a way. I dove in the deep end, but that's just me. And then now I've been doing these types of silicon molds more recently, and I'll explain why in a moment. Rather than using bronze, this is, I just took this off the web. This is a typical so-called white metal, pewter, tin, basically, low melt alloy. You can get these kits, looking on Amazon or eBay, you'll buy one of these kits pretty inexpensively. Certainly, 20, 30 pounds will get you a little kit. You see their little metal ladle, some small files for finishing, because obviously nothing casts absolutely perfectly. This one was based on like a modeling clay that you use to invest into or cast into, and then the little bars down there are the actual white alloy material down there at the bottom. So this is the sort of thing you could safely and pretty well do over a home stove. Not so easy on electric. If you've got gas stove, you could easily hold these little things over the gas stove, 200 degrees, it melts pretty readily, and then pouring it into a mold. The silicon that I showed earlier, you can find most of it will be able to tolerate white metal at about 200 degrees. If you want to go a bit hotter than that, you can find, if you look around, some very specialist high temperature silicon. So it's still flexible, and you can put maybe more like aluminium in there. At the moment, I've been looking around. There's nothing flexible, the silicon-based materials that will go any higher than about 600-700 degrees. So it's certainly not going to be possible to cast bronze, but some other materials, other metals are perfectly possible. So rather than a full mold, which I showed, this idea of a flask, the metal mold I showed at the beginning, in two halves, which will give you a fully three-dimensional object, I would suggest the best place to start is what I would call a press mold. So this is an object. It's actually a little historical Tudor button, but that doesn't really matter. It could be any little simple shape. So you can think of a coin or a little medal, or the sorts of things that many of us may have seen on Thingiverse. A little commemorative coin, or some kind of little plaque, some small, shallow, low relief object. That's the sort of thing we're talking about. And I would suggest probably best place to start is something small. Always scale up once you've got the hang of it. Get hold of some of this silicon molding material. Figure out roughly how much you want. I know, maybe a small golf ball size of each. Mix it together. You have a look at the instructions. You'll find most of them have got between about a 3 and a 5 minute work time, so you can't kind of leave it lying about. You either just squash it down onto a flat surface, or find a little container, shallow container to push it into. I literally just squash this flat using my hand. A bit like using Play-Doh. And then you take the object, invert it upside down, and then press it firmly into this silicon. Press it right down until whatever the back of this object or coin or flat thing is flush with the surface of the silicon, and then just let it sit there. 5-10 minutes later, you can come back and gently just bend this now very flexible rubbery type mold, and the original will pop out, leaving the little void that you see there. And then laying that on a surface, it was pretty straightforward to use the little pewter kit, like the ones I showed earlier, just to melt some metal and then gently pour it, and carefully pour it into that mold. Give it a moment or two to cool down, or if you're really impatient, you can use gloves and you can pick it up and dunk the whole thing in water. But basically, wait till it's nice and cool, bend the mold again, flex out the object, and there you have your little cast object in white metal. And that's very satisfying. It's a really kind of quick, instant process. It doesn't use much at all. And like I said, using a white metal pewter tin casting kit that you could buy right now somewhere like Amazon, £20, probably a comparable amount for a simple silicon kit. So you're looking at 40-50 pounds outlay. Some standard sort of hobbyist things you might have lying around, spoons and spatulas and things like that, a pair of gloves, nothing too major needed. Most kits will come along with some basic safety advice. Nothing like this gives off any particular nasty fumes, so standard keep a window open or have some fume extraction, or in a shed if you have the capability to do that. But all pretty straightforward and within the grasp and wherewithal of most of you who've done any kind of tinkering and making before. So I'd encourage you, if that's something you wanted to try, this is the way to start, really. So little sort of summary, really, to put all that together. Start off thinking about simple shapes. If you're looking at the silicon press molds, um, I would encourage you to start off with the low melt pewter tin. Start small. You can always gear up later, but there are some little learning curves. There's some problems. Why go all guns blazing, something really big and advanced, and it fail, and then you might be put off. So, always better to start off a little small, learn the lessons, and then work your way up. Certainly, when it comes to the 3D prints themselves, no fine details until you kind of really get to grips with how you're doing this, and that's true really of whether we're doing the press molds or the sand casting, or any different way of doing it. Rules that follow all the way through, really, you guys are going to know these, and ladies, very, very well as 3D print enthusiasts. No undercuts and overhangs. Even more so than 3D printing, we know there are tricks, with support and whatever, or multi-part in 3D print that you can get around that. But really, it's a lot more difficult to try and use those sorts of shapes. So you need something which is, to get technical, it's bilaterally symmetrical. So think like a bivalve, like a shell, something that is symmetrical both ways around a center point, and without too many protruding parts initially. Something that will come as no surprise really to most 3D print folks, and that is smooth. You don't want rough textures. You can introduce some textures, but it just brings its own problems in terms of how the mold will work. Certainly with the sand, if there's too much texture, that it can't. You'll pull away the sand with that original object as you try and pull it out. So that therefore it ruins the mold, and therefore any cast you're going to make from it. So I'd encourage you to try and start off with smooth things. So obviously, print them at good resolution. Use all the tricks that I'm sure many of you know for smoothing. So whether it's acetone, whether it's spraying, sanding, a combination of all of those. I'm in favour of. I don't really like acetone very much. The fumes are not very wonderful, and you can over melt your object. So I sand mine or print them at good resolution, and then I'll give them a good liberal spraying in. You can find some quite reasonable acrylic sprays out there, which are considered sort of filler sprays that actually sold as that. So they're used for the car industry for repairs, to usually plastic parts on car bodies. So they're thicker than normal paint. They don't run so much, and they tend to fill. So they will fill some of our little lines and things like that to give you a nice smooth surface. The boring bit, obviously safety. I'm sure many of you are, probably under 18, and that's fine. But and if you're a very practical person, and you approach this cautiously, then sure. If there's any under 18s watching, do get help from adults. Do get permission. Really obvious statement there, but some of this can be quite dangerous. You are working with very hot and molten and liquid metal at the end of the day. Even 200 degrees is a very, very nasty burn in the case of the pewter and the tin. So do be careful. PPE, personal protection equipment. So very minimum, some gloves protect you from the heat. Burns are nasty. Some mask or eye protection. And if you start getting into things like the aluminium or the bronze, like I was doing, you're going to need some kind of fume extraction. Not because it's overly poisonous, just not great, some of the fumes. So either work outside, work in a shed, or have some fume extraction involved. Now, when I was looking, like many of us, I went looking on YouTube. There's some great videos out there. Some enthusiasts who looked at this and thought, right, let's have a go. There are quite a few based in America who they build foundries and forges to melt metal. There's seems to be a big activity of melting aluminium cans down, which is great, sort of eco and recycling and all that. Unfortunately, some folks saw the whole thing of sort of Cire Perdue, this lost wax, the idea that you have a wax thing held in some kind of mold. And I think there's some misunderstanding there, and several people risk serious injury by taking a 3D print and embedding it in clay or in the sand that I used, and then leaving it there, and then expecting to pour molten metal in on top. Now, yes, the sort of temperatures above aluminium, it will instantly liquidize your PLA 3D print, but it's going to create gases, it's going to create molten material. That's all trying to fight its way out, a bit like steam in a kettle. So guess what? It comes exploding back out, and it usually bring the metal with it. I'm usually all over you. It might sound like a boring kind of, lecturing dad thing to say, but please, I saw so many people almost live on feeds getting seriously maimed by pouring hot metal on top of PLA or 3D prints. Just don't do it. Just never try it. It's unbelievably dangerous. So there you go. That out of the way. Now, I'll come back to the live feed in a moment to field any questions that might be out there, or just chat further. But if anyone wants to just make notes of these or take a picture of it, if you want to connect with me because you want to learn more or take this further, I regularly give courses, so you could come over to my studio. I'm in northwest London near Harrow via Hobby, which is my hobby, and the range of workshops and courses which I give, and the bronze casting one has been pretty popular. I can also cover aluminium or pewter as well, how to do that, the whole process from start to finish. Obviously, with the COVID-19 situation, we're not quite there yet. I probably could receive one person and we could safely do that with social distancing, but I think we're nearly at the relaxation of this, that we'll be able to fully start this. And even when it's sort of normal, whatever that may be, I can only have about 3 people at a time anyway for safety. So if that's something that interests you, and that, it's a good way to learn, look me up on Hobby and maybe book on a course and come and try it out. If you're just interested in some things I make and want to just buy finished stuff, and I occasionally make kits to do these sorts of things, then find me on Etsy. So that's the middle link. And if you want to check out my YouTube channel, you'll find most of that actually is me with my other hat on as a musician. So you can have a laugh at all the crazy things I get up to there. But there are more and more, I'm starting to put some more other feeds on there and other videos about my making and 3D printing and crafting and so on. So you'll find those on YouTube. And finally, if you want to just go ahead and hook up by good old email, I'm johnnycope@hotmail.com. So feel free to send me an email if you have got a very specific question that's not been answered in the session we're going to do in a moment, or just want to maybe ask where supplies come from, or something like that. I'll do my very best to answer. I'm kept pretty busy, so give me a day or two, but I'll do my very best to answer any queries that come. So I think we'll pop out of that. I think I'm pretty much running to time. So
great. We've got a couple of questions for you.
Okay.
So the first one is from Rob. What would you recommend? Would you recommend people start the same way that you did, or is there another way? Anything you'd recommend avoiding when you start out?
I'm one of these people. I tend to go in all guns blazing. I think that's because I'd had a bit of I won't bore you with all the biog, but I've done lots and lots of things in life, and I've done a little bit of casting, even way back in school level, back in the late 70s. Yes, I am that old, and we were still doing casting then, so I'd had some practical hands-on, so I didn't feel too much of a stretch. So if you're the sort of person that's had practical hands-on skills, or you've done maybe some welding or some hot work, or you're that sort of minded, you could go straight for the bronze if you like. But I think for most folks, just to reiterate what I'd said previously, just start small. Start with the pewter or the tin, low melt or aluminium. Make it easy on yourself. Unless it's something you're definitely going to do a lot of, then you perhaps don't want to go spending lots of money gearing up to find out then either it's not for you, or it's more involved than you thought, or so on. So yeah.
Great. We've got another one from Leo do you mix your own alloys?
Yes, I do. So alloys only really come into play when we're talking about things like bronze or brass. Aluminium is aluminium. So if you're going to melt down cans, the little sort of caveat I'd attach to that is, some of you may know that drinks cans obviously have print on the outside, so that's ink. That's going to liberate some fumes, so watch out for that. And a lot of drinks cans actually, because aluminium is now, they've decided that it's vaguely mildly toxic, so perhaps you shouldn't be ingesting it. They'll be skinned inside with a very thin piece of plastic, actually, in most, say, like a Coke can, so that the drinks are not directly contacting this very thin aluminium. So that will also get burnt off. So that's going to produce fumes. So if you're burning aluminium, be very careful. You want to be outside. You want to be away from it whilst that all gets burnt off. Once it's aluminium, that's fine. You can look up some alloys of aluminium. You can introduce some things into it which make it a bit stronger, or make it run better, or cast better details. Look up those online. Probably haven't got time to go into the detail of those now. For bronze, because I wanted to recreate this sort of ancient bronze, I wanted these axe heads I was making to be as accurate as possible. So I'm making them now for museums and things, and reenactors, so they want to be correct. I wanted to control my mix, so I buy actually just copper pipe that you might find in a DIY shop. I hammer it all flat, chop it up into chunks, I introduce that into my crucible. And the weird thing is, if you try to cast with just copper, it's actually got one of the higher melting points. It's well over 1,000 degrees. But just by introducing between 8 and 10% of tin, that drops down to under 1,000, about 950 degrees, which makes it a little bit more manageable. It's still extremely hot, but that makes a very nice alloy, which casts well, pours well, stays liquid for a reasonably long time, and has some strength behind it. If you have heard the term brass, that's effectively the same mix but with zinc added. Now, I'd say definitely don't do that, because zinc is one of the few metals that when we get it hot, certainly for pouring at melt temperatures, it actually gives off really very nasty fumes. You can actually get zinc disease. It kind of feels like really bad flu, and it's really not very good for your lungs. So be a bit careful, a bit cautious as you get into this. Either ping me an email if you think you want to go that way, or I would imagine most of you will just do some research first before you dive at something like that.
Great. And then I think we've got one final question from Neil. Do you have to do any post-processing to finish off the parts that you've cast?
Well, at a very simple level, and one thing actually, I didn't get a chance to add this to the PowerPoint, so I'm going to answer that in a rather roundabout way, if I may. In that, one thing I forgot to mention was some folks may have come across this before, PMC, which is a modeling clay, which you can buy sort of a copper version of it, but actually silver. So it's a polymer silver in kind of it's a bit like Play-Doh clay, and it presses into press molds very, very well. When you press it in, then you leave it a day or so to dry, and then you carefully pry it out, and then it's a kind of a bit like the air dry clay, like Fimo, that sort of stuff. And then you can fire that using just a blowtorch, the sort of thing that a plumber would use, or you could do it even over a stove, and that sinters down, to use a technical term. It renders down into solid silver, and that actually comes out very clean because of the way it's done. All the other methods we've looked at, you're going to get what's called flashing. So a two-part mold, maybe it leaks slightly at the sides, and where you've poured it in, you've got what's called the gate. You've got the little hole that I'm pouring into, and maybe you pour in a bit extra as well, so you get this little blob at the top called a sprue, and you've got to cut that off. So you might want to hacksaw that off, or use bolt croppers, and then you have to just a little bit of filing, what's called fettling. So a little bit of grinding, filing. Nothing, too massive. It's the sort of thing that you might do to a 3D print anyway, to finish it off. It's only that level of finish. Depends how perfect you want to be. If you want to take the thing to a very high polish, then obviously you've got to start talking about rouge wheels and polishing kits, and it's a bit more involved. But yeah, most things come out. It's usually like a lot of these things. The more time and effort you put into preparing the original, making it really nice and smooth, and preparing the mold, however you're doing it, the clay or the press molds. If you make that nice and accurate and well fitting, then you'll get a good clean cast, and it won't need too much finishing. So